Hello, today is May 27, 2024. Today we're going to talk about physics. Again, it's still in electric field. Today we're going to talking about electric field, and the source is due to a disk. Before we talking about the disk, let's review the ring that we talked about last time. So let's say if this is a ring, from the center we draw a line perpendicular to the ring, and then this is our x-axis. This is the point P, and then the radius of the ring, let's say, is A, and then the total charge distributed uniformly in the ring, that's called Q ring. Okay, and then based on the formula that we had last time, the E actually is indeed in the x direction. Why? Because each element had an electric field. They have two components. One is in the x direction, one is in the y direction. Because the y direction, they all cancel out, so all we leave is x direction. That's equal to K times Q, which is the total charge distributed uniformly around the ring. We call it Q ring, times B, which is the distance between this and this. And then we have A squared plus B squared in the x direction. Okay, now today we're talking about the disk. The difference between a ring and a disk, because the disk is going to be covered everything in this plane. Again, from the center we draw a line x, again at the point P. This is the origin, and then we got a little ring right here. Again, this is our random picked up the ring, and if this ring, we can integrate from 0 to r. By the way, the disk, the radius is capital R, and then the total charge for the whole disk will be Q disk. Again, there's a very important thing we want to introduce. It's called sigma. Sigma is the charge density. When we use the sigma, we typically talking about the case in the whole area. Remember, when we derive this, we use the lambda, right? Lambda again is the charge density, but this is typically when we're talking about linear charge density, which means along a line, but this is for the whole area. Okay, so those are the information we have to know, and then we try to get the electric field at the point P around every component in this disk. Okay, so here there's one concept I saw a lot of people get confused with. It is how do we integrate like that? We basically have to find a technique such that we're going to cover each part of the disk, right? And then we have to start from one element such that as we integrate from one limit to another limit, the element expands that will basically scans through the whole area. And then the best way to do that is use the ring. right? Imagine if we have a small ring and they keep expanding, and they eventually cover the whole disk. We will get the idea. Since we already know how the electric field distributed at a specific point P, we can use this result right here. The, the key thing is, even though this result, for the ring case, that's our final result. But in this case, ring is our starting point, right? So this is our infinite small element that we're going to integrate with. So this result right here, again, we are not going to talking about the direction, we're just talking about the magnetic. So our dE actually equal to exactly the same thing, right? Okay, I'm going to copy the Q ring times P A plus B 3/2. Okay. Now we have to change this to some element. That way we can put a limit with and then we can integrate with. The second part of that most people get confused solving this problem is we're going to use the thing called dr. I will explain you right now. So if we cut the ring right here, let's say we cut it right here, and then we expand it, we will have something like this. Okay, so this is our inner ring, right? This is our outer ring, and then the thickness of this is the dr. Notice this too. Instead of like straight, I could tilt it because the inner ring is a little bit smaller than the outer ring, right? And then in this problem, we just assume the same. Why is dr itself is very small. So the whole area we can roughly think of is 2 pi r, which this, let's say the radius is r right here. Then 2 pi r will be the circumference of this circle, which is indeed from here to here, times dr, we will get the whole area. And then the whole area times sigma, which is the charge density. We basically had the whole charge in this area. So that's indeed is our Q ring. And then we can use this to replace this Q ring. Let's see. So again, since we have dE, our E will be the integration of dE, right? And then we try to integrate from 0 all the way to R. 0 to R. And then what do we have? We're going to copy this, which is K times Q ring, which is this guy, 2 pi R dr sigma times B, and then over A squared plus, I'm sorry, in this case, the A is this guy right here, right? If we move this to this graph, this A corresponding to the R right here. So indeed, A squared will be R squared plus B squared. B squared is the same because that's the distance from the origin to the point of interest. And then 2/3. Okay, and then we're going to integrate from 0 to R. The third thing that most people confused is the dr. Because when we're talking about dx, dy, that's the specific direction, right? But dr basically is from the origin all the way like that. Okay, so the dr actually is the vector field. Again, you have to get this conceptual correct, so that way you will understand what we try to do. From the small ring, we expand it. Okay. And then now let's look at how we to do this. Again, the b is the distance from 0 to point P. That actually is a constant. So number one, we're going to move every constant outside of the integration symbol. So k, again, is a constant. 2, I'm going to leave inside. You will see y. And then pi is the constant. dr is the variable, right? Sigma is the constant, and then b is the constant. And then we're going to integrate from 0 to r. So what we left is 2r dr, then r squared plus b squared, 2, 3. Okay. Now we let u square equal to r squared plus b squared. And then du, no, not u squared, just the u. And then du will be d this, right? Since b is the constant, so that go to 0, and then that will be 2r dr, which is exactly the numerator. So now our original E is going to be equal to k pi sigma b. We copy that. And then the integration will become, because the whole thing is u, 2, 3, and then the top will be du. Again, since we changed the variable from r to u, the limit is not going to be 0 and r. To simplify, we just randomly name them to be n, mn. And then that will be equal to k pi sigma b. And then we can rewrite this as the following, as u negative 3 2 du. Again, this is very important. If we have a to the negative power, let's say s over t, that is exactly equal to a negative a to the positive s over t. So both backwards, the transition you need to be very, very familiar with. Again, for this part, how do you integrate that? That would be something, if you are not familiar with this, I strongly suggest you to review your calculus book. So that would be negative 2 over 3 plus 1, and the numerator will be u to the negative 3 over 2 plus 1. Basically, it's the exponent plus 1, and then u to the exactly same exponent. So that will be k pi sigma b times negative half u to the negative half. That will be k pi sigma b negative. When you divide a fraction, is similar as multiply the reciprocal of the number. So this is actually negative 2 right here. I'm sorry, negative 2 right here. And then u to the negative half. And then, again, that's m to n, m to n. Okay. So now, let's continue. So now our E will be equal to k pi sigma b. We're going to plug in the u back to this one. Actually, it's negative 2. how do we plug in back there? Let's see, because u equal to r squared plus b squared. So it's going to be r squared plus b squared negative half. No, we use the original limit. And then we are going to substitute this. Okay, so it's going to be this limit plug in, subtract this limit plug in. So will be r squared plus b squared negative half subtract 0 squared plus b squared negative half. Okay, so that will be negative 2k pi sigma b. This can be rewritten as the following: r squared plus b squared. Again, we are using this one right here, this formula. And then this will be gone, and then b second times this will be b2 times negative half. So this can cancel out, that will be subtract b, 1 over b, okay? And then we can plug in the negative number inside, so what we have is let me see, it's 2k pi sigma b 1 over b subtract r squared plus b squared. So that's our final result. One thing I want to share with you, so we just derived the disk, right, from the center at the point P right here. What about we expand this disk to infinity? Then it's going to be a very large plate, right? So for the very large plate, then how do we look at this? That means the electric field in front of the plate will be the following. Would be 2k, k actually equal to 4 pi epsilon 0. The epsilon 0 is called the electric constant. So you will have 2k, you just plug this in, 1 over 4 pi epsilon 0 times pi times sigma times b. Now look at this. When this going to infinity, right, the r of the disk goes to infinity. So this is infinitely large. Even though you take a square root of it, still an infinite number. So 1 over infinity, you got 0. So this one is gone. So what we have is just 1 over b. B cancel out, pi cancel out, 2, 4 cancel out. So what we actually have is the charge density over 2 epsilon 0. Okay, so again, the direction of the electric field is going to be like that. So let's say if we have infinite many large the plate, and then any points, if we try to follow the electrical field, it is always equal to sigma over 2 epsilon 0. And then the direction will be perpendicular to that. If this is a positive, it's go to that way. If it's negative, it's go that way, right? But the value is always going to be like that. And what if we have like a parallel infinite many large? This is a positive and this is a negative, right? And then that I basically leave as the homework assignment for you guys to think about it. Right? Basically, it's pretty simple. We go to the value, you just have to figure out the direction, and then you do in the superposition. So that result actually is going to help you when you try to calculate the electric field of two parallel plates. One is positive charge, another one is negative charge, and then you need to find any points over there. So that's why the charge the electric field in between any of those is the constant. Again, that's enough hint for you guys to think about this. And then leave on the comments if you have any questions. Please remember to subscribe and then leave anything in the comments, because that really helps me. I'm just starting working on this YouTube channel. I could change anything based on my understanding and new updates. If you just doing the search from previous keyword, you might have a hard time to find me. Sometimes I even had hard time to find my own YouTube channel. But if you subscribe, you always can find me. Thank you again. Okay, see you guys next time. Bye bye.